All right, so here we go. This is going to be problem number 1079, letter tile possibilities. Let's just check the audio is working and the chat is up. Or begin. Hello, hello, hello. Let's just check the audio is working. Very good. And let's get right into it. So this is another LeetCode problem. I'm just going to try to do it as quickly as I can. Well, reasonably quickly. Let's see how long it takes. So, n tiles. Each tile has one letter tiles printed on it. Turn the number of possible non-empty sequences of letters you can make using the letters printed on those tiles. So tiles AAB is 8. Possible sequences are A, B, AA, AB, BA, AAB, ABA, BAA. Okay. Okay, I think I know what this is. 188, 1 through 7, uppercase English letters. This is a multinomial type of a question, meaning it's the permutation, number of permutations, divided by the factorial, right? Number of permutations, divided by the permutations of each of the like individual letters. These are all uppercase letters. Okay, so we could just use a frequency map to do this. Oh, there's only 7, so it shouldn't be too. This is not too bad. You could do this pretty quickly. So one issue though is also sequences of size 7, 6, 5, etc. A little more complicated because you can perform the same calculation but removing one letter at a time. So that's if you could use the multinomial calculation, which would be like n factorial divided by each of the factorials of the respective frequencies. You could do that. Also, I think memoizing the factorial might be a good idea too, just as an aside. The factorial function. So that'll give you the number of sequences using all of the letters, right? But using only 2 letters now gets a little more complicated. Yes. Interesting. Trying to think how best to do this. Basically, you would just subtract one of the letters. You could recalculate this for each n and take the sum and just remove. It's actually not for each letter, it's for each subtracting 1 from each frequency, I suppose. Let me think now. Okay, I mean, yeah, I guess it's a little more complicated than I gave it credit for. Yeah. Excuse me. Good question. Not as easy as I thought. This part is straightforward, but this part is a little bit more involved. Or not this one, I'm sorry, this part is straightforward. This part is a little more involved. 3 factorial divided by 2 factorial divided by 1 factorial, which is just 6 divided by 2, which is 3. But what about these ones? Well, if you subtract the a, then you have 2 factorial. So all of these are going to be 2 factorial. Depending on which element you remove, though. Let me see if I can simplify this somehow. That's a good question. It's a good one. Not so obvious, not as obvious as I thought. Thought I had it immediately, but it's a little more sophisticated. I don't think it's too sophisticated, too crazy. I don't think so, but it's enough. I mean, it's enough. So if you had 2 factorial over, we removed one a, and then 2 factorial over removing another a, which actually should be the same. So it's really just for each possible character you could remove something from. So there's only 26 different possibilities. And then removing b, if you keep both a's and remove the b, and that differs from 3 factorial over 2 factorial, 1 factorial. And this ends up being 2 factorial over 1 factorial, 1 factorial, plus 1 over 2 factorial, 0 factorial. Interesting. Yeah, I mean, it's 26 choose 1, and then the next set to consider would be 26 choose 2, and 26 choose 3, 26 choose 4, all the way up to 26 choose 7 at most, which actually there's a lot of different parts to that. There are a lot of different elements to that, which it's not so obvious. Yeah, it's actually not that easy. It's not that easy. No, it's not. I don't know. I need to think about this one, huh? What if I did permutations with removing elements? So ABC, AB, AC, BC, ABC has 6 permutations. Let's do AB, actually, it's easier. So permutations for AB, it's just AB and BA, right? And then also A and B. If A, B, AB, BA. Interesting, so it's 4. ABC, I think, end up with something a little more sophisticated, more complicated. You end up with A, B, BA, and you could place a C in a few different spots. So you could put C in front or to the right, CA, AC, CB, BC, CAB, ACB, ABC, and then CBA, BCA, or excuse me, yeah, BCA or BAC. Okay, so you end up with 2 plus 2 plus 3 plus 3. Okay, 6, 10? 10 possibilities total. Okay. So with 3 unique characters, we end up with 10 possibilities. And plus the original 14, excuse me, it should be 14 total. I don't know. No. I guess there's the empty one as well. So 1, 2, 3, 4, 5. It would be like 5, including the empty sort of string. And then so you'd end up with actually a C in the empty string too. You have to add 2 more. Or yeah, C. So you get, if it was 5, we then get 10 plus another 6, 7. It's like 18? 5 to 18? Is that what I ended up with? 5 with just AB, and then adding another distinct character. We ended up with really should be 6. Sorry, excuse me. 1, 2, 3, 4, 5. No, 5. 5 with AB. Right, empty A, B, AB, and BA. And then adding another distinct character, we got 1. So we have 1, 1, 1, 2, 3, 4, 4 2s, and 6 3s, which we had 11 of these. So excuse me, we go to 16 then. 11 plus 5 is 16. So 5, 16. And then if we went to A, B, C, D, now we take all of those and place a D. How many elements do we have that have 2? It's 1, 2, 3, 4, 5, 6. 6 of them that are size 2. 3 of them that are size 1. 1 that's size 0. And 9, 10. And then we had 6 that were size 3, which was the 16 total. And then that becomes now the size 0. We keep the same 3s that have 1, or the ones that have 3s, keep those. The size 0s, keep those 2. We add 1 character, so now we have another 1, size 1. The size 2 elements, we take each of the previous size 2 previous size 1 elements, and put the character to the left or to the right. So we multiply that by 2, so 3 times 2 is 6. We add that to what we already have, so we get 12. That's for a unique character, right? This is way for a unique character. So yeah, all of those size 1. There's A, B, and C. We add D to the left or to the right, so now we get all the previous size 2 values that we had plus those 6. Now the previous size 3, we said there was 6 of them, and now we take all of the size 2, and we have 3 different spots we can put the D. So we have 3 times 6. So we get so here we're at 1, 4, 12, 24, and then for 4 element. For the 4 element sequences strings, we would have the 3 element strings that we had previously, multiply those by 4. So we had the ones we had previously. Oh no, excuse me. There's 0 4 element parts up to this point. We take all of the previous 3 element parts and put a D in any position, which there are 4 different possibilities. 1, 2, 3, 4. Yeah, so 4 times the previous, which is 6, which we get 24 again. So we get 1, 4, 12, 24, 24. And then if we went 5, 6, and 7, so going to 5, we do the same thing. We say 0, 1, 4 plus another 1, 2 is 12 plus another, I think the previous 4 times 1. Oh no, excuse me, times 2. Yeah. And then 3 is again, it's 24 plus 3 times the previous, which is 12. And then 4, we're going to do 24 plus the previous, which is 24 times 4. And then 5 is going to be the previous, we have 0, and the previous is 24, it's times 5. Yeah, so something of a pattern there. So we're only going up to 7 elements, so following this pattern is not too bad. Yeah, this is for unique, and then 6 elements, the 7 elements, if they're distinct, is a similar kind of a thing. So it's not too hard to calculate this in this way. Excuse me, using some dynamic programming. But the question is, what if we add a character that we already had, right? So for instance, we have ABC and we add another A, right? A duplicate. Well, ABC we said was, I think it was 1366, right? That's what we had for ABC. And when we add an A, we don't change 0. We don't actually change the 1s at all. We still have 3 1s. The 2s, we could take all of the previous sequences and fit the A in there where there were 1s. So you had ABC, and we get AA, AB, AC, right? That's all new. So we could take, excuse me. Yeah, so the number of things that there were, well, no. So some of those would be repeated, right? So the previous ones we had 6 of them, and it was AB, AC, BA, CA, AB, AC, BA, CA, and then BC and CB. Now we fit an A in there, and we get, with ABC, AB and C, we get AA, AB, actually AA twice would be AA, AB, BA, AC, CA, and obviously this AA is duplicate, and this AB and BA, AB, BA, AC, and CA, all of those have already been covered, right? Those are, so well, we only get 1 more there, actually, plus 1 somehow. And then for 3, we had 6 already, which was the permutations, ABC. I'm wondering if there should be more than that. No, I think it's fine. It's just the permutations ABC, ACB, BAC, BCA, and BCAB, and CBA. Okay. 6 permutations. And then now again, you could fit A in all these different positions. So really everywhere you see an A, well, yeah, I mean, there's a lot of duplicate stuff, I guess, going on here, like ABCA, and also later down the line, ABCA again, like these are just the same one twice, and AABC, and then you put an A to the left of ABC, you get AABC, put it to the right of A and ABC, you get the same thing, AABC again. A BAC later on, same thing, is shows up again later with ABAC. So A to the left of BAC and A in between the BC of ABC. So there's a lot of duplicates here. Just kind of peculiar. Yeah, I mean, it's kind of easy to do the unique characters. Excuse me, but when they're not unique, it's not so obvious exactly how they interact. The previous sequences. Yeah, I'm trying to find some kind of inductive argument or some kind of maybe a dynamic programming approach. So with the duplicate characters, it's a little more complicated, for sure. Alternatively, I could calculate the yeah, well, Problem with doing it this way is I was gonna say I could calculate, try to divide out the permutations of the duplicated values, but it sort of doesn't work or make sense because the string sequences that don't use all of a particular, like don't use all of the characters, in those cases I wouldn't have as many to divide out, so to speak. If that makes sense. Because they're basically different subsets of the characters. I mean, 2 to the 7th isn't that many subsets. Like I could just go through all the subsets. I mean, it's another way of doing it. That may be the best way to do it, actually. It's 2 to the 4th times 2 to the... I think it's just 128. 2 to the 4th times 2 to the 3rd. 16 times 8. It's, yeah, I'm pretty sure it's 128. 6 times 4 is 8, 428. Okay. Yeah, I mean, I could also just go through 128 different sums. And there's that too. And sure, I guess. Excuse me. Oh. Oh. What? That's another way of doing it. I mean, small enough, this question, that you could do it that way. I think one of the problems with that is some of these numbers, even though the subsets will be different, because these are duplicated characters, the actual strings, the frequencies are the same. The frequencies of these characters, the frequency map's the same. So, trying to think. I'm wondering if I should create the string as a key, and just if I've already processed that key, don't process it again. That sort of a thing. Could do that in theory. Trying to think. Yeah, I mean, whether or not that frequency map has already been processed is kind of the question. That's really what I'm going for here. 26 to the 7th is kind of a large number. I think that doesn't fit in an integer. Trying to think how to do this. I don't know. Give me 1 second here. Okay, so like this. This is like thousands, 100,000s, millions are here, millions, billions. Yes, just doesn't fit. It fits in a 64-bit integer, but not in a 32-bit integer. Gee. Trying to think, how can I do this? How can I do this? Basically, I was thinking about encoding the frequency map as an integer and putting that into a hash set to keep track of it, of which ones have already processed. Could make a string and put that into a hash. I mean, it's probably the easiest way to do it, quite frankly. Just sort the string. Create the string, sort it, and then create the hash. Put that in hash. Yeah, that's probably the easiest way to do it. That's probably the easiest way to do it. Okay, we'll do it that way. I like that. I like that approach. So we're going to say const int n tiles.size. Let's Let's call this S instead of tiles. This is a good question. It's a challenging question. I'm gonna say int I is 0, I is less than. Okay, total. And total. Okay, now we're gonna say for each bit, starting off at 1, j is less than n, or j is at 0. Increment j, bit shift by 1. J is less than n. I'm gonna say if bit and I, and we're gonna say string current. Okay. Current plus equals string of j. And then we're going to have an unordered set strings processed. And we're going to say if processed current count current, not processed, processed dot insert current, and have a result at the end. And we'll do the multinomial calculation, get the frequency here, do the multinomial calculation. Frequency, well, let's do it this way. Okay, after each of these, we're gonna say fill. Let's do it here, actually. Okay, and now the result, we could say for each I is 0, I is less than, or let's do k is 0, k is less than 26, k, calc starts off at, oh, we want the factorial as well, which could be done at compile time, actually, but we're not going to do that at compile time. Let's do this. So for int I is 0, I is less than 7, plus I, fact 8, and we're going to say fact of, let's make them ones actually, let's keep it simple. Fact of I is going to be fact of I minus 1 times I, right? Less than equal to 7, or just less than 8. So even easier, we're not going to use a function, we're just going to make a an array. So it'll be 1 for 0, 1 for 1, and then for each value of I, multiply by 2 times 1 to get 2, fact of 2 factorial. 3 is going to be 2 times 3, 3 factorial, etc., all the way up to 7. Okay, that's fine. Just use factorial that way. So now we say calc is going to be fact of current.size. And then we have the frequency as well. Just divide by the respective frequencies, factorials of respective frequencies. So calc divide equals fact of frequency of k. Right. Zeros will be ones, so that's no problem. And result plus equals calc. And that should do it. Something like that. Something along those lines. It's kind of involved, I realize, but a lot of pieces to it, I guess. This had a very high acceptance rate, this question. It took like 30 minutes. Oh no, it's wrong. 9, expected 8. Oh, I think I'm missing one more. Yeah, I think I have to subtract 1 as well. This includes the 0 case. This includes the empty string. So that's one string that I should remove. I could do that too. That also works. I should also remove the empty string. Yeah, okay. Let's do some random test cases. More interesting things. And then we'll just put like, all right, something like this. Oh, I did it wrong. Oh, I forgot. Forgot something important. Yeah. Forgot something important. Gotta sort. Gotta sort the keys. Yeah, I forgot about that. There we go. That should be correct. All right, I think I want to go for it. Let me try some simpler cases. A, B, C, and then just random stuff. All right. I probably should try, like, I could try more things than this. I'm gonna go for it. This could be right, could be wrong, I'm not entirely sure. I think it's right, but we'll see. Oh, got it. Okay, very good. Not bad. Yeah, half an hour is not great, but relatively quick solution. It's not the fastest asymptotically, but it's reasonable given the constraints. Given the constraints, reasonable solution. It's not beating 100%. We'll submit it 3 more times and then go to the next thing. So, unknown network error. Okay, of course there is. I have to refresh the page. Oh, got it. Hey, sweet. Check that out. So that's 3, 1, 2, 3, 4. We'll submit it one more time. Yeah, 100%. Nice. Hail victory. Hail victory. Not bad. Yeah, I didn't really explain it too much. I mean, hopefully it makes sense. It's basically going through all of the possible like selections you could have for the substrings or subsets of characters, and then sorting them to make a unique key, and then using the frequencies to calculate the multinomial amount of each one, and then just using the sorted set of keys to make sure you don't double count anything. This is obviously exponential in the number of characters, but there's only 7 characters, so it's not too bad. Ultimately ends up being a relatively fast solution. Beats 100% of the solutions. So yeah, I mean, it's okay. You know, it's not, maybe, you know, if this was a larger number, it would be a little more challenging, I think. You couldn't really do it this way. You'd have to kind of take a different approach. Slightly different approach, I think, but I'm not sure how I would do this if this number were a lot larger. I'd have to think about it a little bit more. I think because it's only 26 uppercase English letters, this probably could still be done on the more efficient side, even if this was a little bit larger. That's my guess. I'm not sure about that one. That might not be true. I've had employers. I would say things live on my stream that I've had employers hold me to it. Those things, and I get really aggravated because I'm like, I just need a job. Why are you making me like conduct research during an interview? What's wrong with you? Why would you do that? I just want to get a job. Like, I just want to get paid. I'm not trying to conduct research on the spot. It's like insane. I guess on the one hand, I could take that as something of a compliment that they think I'm capable of that, but on the other hand, it's very disappointing because I need to eat. I need food and money and a job and other things. But anyway, so it's flattering, but also mostly disappointing because usually like it's too hard to figure it out in 15 minutes or whatever it is. All right, so I'll stop here and start another question. I think, yeah, we'll start another question. We'll get right into the next one. So yeah, if you like that, then like the video and follow the subscribe to the channel, and